Hi everybody, this is lesson 4 and we're going to be talking about equations of perpendicular bisectors today. So first we're going to have to review a little bit of vocab. Perpendicular, which is this symbol, we've done that before. That is when two lines intersect or cross to form 90-degree angles. So if we had a line like this and we had another one that went through it and it made 90-degree angles when it crossed, that means those two lines are perpendicular. And then a segment bisector, it means that you've got something like a line that is cutting through a segment and cutting that segment into two equal parts. So if we had this segment, and a segment is a line that has endpoints, so it's a certain length, and we had some other line that went through it and cut it in half so that this piece was equal to that piece and there was two equal parts, then the line that's cutting through the middle is a segment bisector because it's bisecting a segment. And something that's always going to be true about that is that it'll always cross at the midpoint of the segment. So that's basically, the big idea of those two vocab words. Now we're going to combine those two vocab words together and we're going to do perpendicular bisectors. That's probably going to be a little bit familiar to you because that's something we did in the beginning of the year. Remember when we used the compass and we made two circles that crossed and then we would draw a line down the middle? So those were something that we always did whenever we were making perpendicular bisectors. Okay, so we did two circles around two endpoints. That would make this line here be the segment. It would be cut in half so that the two sides were the same length, and the line that went through the middle made 90-degree angles. So that was a perpendicular bisector. Now we're just going to do it with a graph and some equations and formulas. So this is what we're going to do. We're going to start off by figuring out the midpoint because we know the midpoint has something to do with this because we know that the line that we're trying to create is going to pass through the midpoint. So let's start there. First, let's find the midpoint of this segment. So we've got A and B. I'm going to call A x1, y1, and I'm going to make B x2, y2. If you wanted to switch those, you definitely could, just so you know. There's nothing telling me that I have to do A before B, but I usually do it just in the order that I see them in the problem. So we've got those as our pieces, and we're going to plug those into our midpoint formulas. So the x value for the midpoint is going to be half of our two x values added together. So that's 3 plus -5. So 3 plus a -5 is the same thing as 3 minus 5. And I'll just finish this one out. So we've got x value of the midpoint is half of -2. And that means that half of -2 is -1. So our midpoint is going to have an x value of -1. And we can figure out the y value by doing the same thing we just did, but now using the y values in parentheses there. So we're going to do half of the two y values added together, which is 8 plus 4. So 8 plus 4. So the y value of the midpoint is half of 12. So the y value of the midpoint is positive 6. So that means our midpoint is -1, 6. So if we look at our graph, and we've got this, let's count -1 to the left, plus 6 going up. That's going to put us right here. And you might even be able to see that that's the midpoint just by looking at this graph. You could tell that this piece right here is the exact same size as that piece over here. There we go. That piece matches that piece. Exact same size. So this is our midpoint. So that's one piece of this done. Now, we know that any sort of segment bisector is going to go through that midpoint. Now, we're not sure if it's going to go through like this, or like this, or like that. Any one of those is going to be a segment bisector. But in this case, we want it to be a perpendicular bisector. So that means that we have to make 90-degree angles. Now, in one of our earlier lessons in this unit, which I've done videos for, we talked about what happens to the slope when you have something perpendicular. So to review that, if you have something parallel, the slopes are the same. If you have something perpendicular, the slopes are going to be negative reciprocals. Okay, so that means that if you had, let me use a random example, 2/3, and that was your slope of a line, you would change that to be the opposite sign. So this is positive, so the next one will be negative, and reciprocals, so that means you're going to flip over your fraction. So the 3 goes on top and the 2 now goes on bottom. So that means that if you had two equations where the slope was this on one and the slope was this on the other, those two lines are going to be perpendicular. So let's use that for this. We know that we could figure out the slope of segment AB by plugging into the slope formula. So we're going to do that, and then we're going to figure out what the slope would be for a line that's perpendicular to that. So we're going to do the negative reciprocal of whatever our answer is. So let's go ahead and try that. So we've got the difference in the y values, so y2 minus y1. So that is 4 minus 8. And that's going to be over the difference in the x values, and we're going to do x2, so negative 5, minus x1. So that means we're going to subtract the top. We've got 4 minus 8, which is negative 4. Negative 5 minus 3 is going to be negative 8. And when we reduce that, that's going to be 1/2. The negatives cancel out, and 4/8 equals 1/2. So that means the slope of AB is 1/2, which you might have been able to just see from the picture. Rise 1, run 2, up 1/2. So we can see that, and we know we're correct that way. Something that's going to be perpendicular is going to be the negative reciprocal of that. So this is something positive. We're going to change it to something negative, and we're going to flip over our fraction. We're going to do the reciprocal. So the 2 was on the bottom, it's now going to be on the top, and the 1 was on the top, it's going to be on the bottom. So our new slope is going to be negative 2. So if you were to just graph this, you might be able to just say, okay, let's go down 2/1, down 2/1, and make your graph that way. But I'm going to show you what to do if you don't have a graph. So the equation of the perpendicular bisector, we're actually going to use our point slope formula that we had in a previous lesson. So that's this. So we're going to use this because it's the point slope formula, and we have the two important things that you need for that. We have a point that we know is on the line, the midpoint. We know this point is definitely on the line that we're looking for, and we have the slope. We just came up with it. So that means we have enough information to plug in here. So I'm going to write this information in another color. That way we've got all of that. Because having different x1s, y1s, and m's can get this to be a little bit confusing. So what we're using for this is we're trying to do the stuff that has to do with the new line. We're going to try and draw a line that goes through M and has a perpendicular slope to the original. So the slope that goes with the line that we're creating is this. So M is going to be negative 2. And the point that's on our line is the midpoint. So we're going to use negative 1, 6 as our point. So negative 1, 6. And we're going to plug that into our formula. So y minus y1 equals the slope times x minus x1. So x minus a negative 1 is x plus 1. And then we're just going to put that in y equals mx plus b form. So y minus 6 equals negative 2 distributed to both of these. And then we're going to get the y by itself. And that's going to be our equation of the line. And when we graph this, it should look correct. Okay, so we have an idea of what it should look like. It needs to go through the midpoint, and it needs to be perpendicular to our original line, which means it's going to have a negative 2 over 1 slope. So let's graph the line. The line is negative 2 x plus 4. So the plus 4 means that it has a y-intercept at 4, and the negative 2 over 1 means we're going to go down 2 over 1, down 2 over 1, and make our graph that way. So we go like this, and then we're going to do the opposite direction, which is going to put us here, and keep going up. So we could tell that this is correct because first of all, we went through the midpoint and we definitely needed to go through the midpoint. So that's good. And we also needed to make sure that we had perpendicular lines, which we do because this slope is up 1 over 2, and then the other slope was down 2 over 1. Those are negative reciprocal slopes. So we did this correct. We ended up getting a perpendicular bisector. It's perpendicular because we've got 90-degree angles, and it's a bisector because both of these halves are the same length. We know they're the same length because it crosses at the midpoint. So that way is the algebraic way of doing it. We didn't really rely on the graph too much. The next example, I'm going to show you how to do the exact same thing, but I'm just going to rely on the graph a little more. It's a little bit faster to do it that way. So first, we're going to figure out what we're doing. We are going to try and find the exact same thing that we just did. We're going to try and find a line that is perpendicular to this segment, and it's going to cut that segment in half. So the first thing is let's find the midpoint just like we did before. That means we're going to start on this end and that end and go in the same amount on both sides until we meet them at the middle, which is right there. And some of you guys may be able to just like see that and know where the midpoint is. And if you do, that's fine as long as you're going to be correct every time. The way you go about doing it doesn't matter too much. If you prefer to find out what these points are and do the midpoint formula like this, then you can absolutely do that too. So our midpoint is the point 1, 6. The slope of this line, we're going down 1 over 1. So that means the slope is negative 1 over 1. The slope for a line that's perpendicular to that is going to be the negative reciprocal of negative 1 over 1, which would be positive 1 over 1. And then the equation of this line, that's going to be the combination of going through the midpoint and having that perpendicular slope, is going to be figured out by doing this. We're going to just combine the two. So we're going to start at the midpoint and we're going to do the slope of 1 over 1. So up 1 over 1 puts us here, up 1 over 1 there. Keep doing that. Then go in the opposite direction. And your line is going to be this. And if we were going to figure out the equation of that line, then we can do so just like we would for any sort of y equals mx plus b situation, because we know the slope is going to be 1 over 1. So we've got y equals 1x, and then plus b is going to be the y-intercept, which is right here, and that's up 1, 2, 3, 4, 5, so plus 5. So the answer for this one is y equals 1x plus 5. If you wanted to try that using this process by using the formulas, you're going to get the exact same answer, and you can do it whichever way you want, as long as you have the graph in front of you. If you've got it like this next one where there is no graph, then you have to use the formulas. So I'm going to do this next example with you guys over the video, but then the next page there's 2 more questions that are based on the same thing. So I want you guys to try those other ones on your own, and I'm going to put the answers online so you'll be able to see all of that and check your work. And also the lesson 4 homework, it's up as an assignment on Google Classroom, so you're just going to post it in like you did all the other ones. So let's focus on this last question. We're going to start off by doing the midpoint like we did for the other ones. This is going to be x1, y1. This is x2, y2. And we're going to plug in for all of this. So the midpoint, we're going to do half of the 2 x values added together, so that's 5, plus a negative 11. So that's going to be half of negative 6. So that's negative 3. And then you're going to do the same thing for the y values, which is going to be negative 5 plus 7. So that's 1/2 of 2, which is 1. So the midpoint here is going to be negative 3, 1. So our next part is going to be the slope. We're going to use the same x's and y's as we did before for n and for y. So we're going to do the difference in the y's, negative 5 minus 7. And that's going to be over the difference in the x's. So that's going to be 5 minus a negative 11. So that's the same as plus 11. So the top is going to be negative 12. The bottom is going to be 16. And that reduces to negative 3 over 4. And again, we're trying to find the line that's perpendicular to this. So we're going to do the negative reciprocal. So the 4 goes to the top, the 3 goes to the bottom, and it's negative, so it becomes positive. So this is going to be our slope for our equation. So the equation that we're doing over here, we're using our answers from the previous 2 parts. So the midpoint is negative 3, 1. So that's going to be our, let's do this. This is going to be x1, this is going to be y1, and this is going to be m for the equation over here. So y minus y1, so that's y minus 1, equals the slope, which is 4 over 3. And then x minus x1, so that's x minus a negative 3, so that's plus 3. And then we're going to get y by itself. So we're going to do y minus 1 equals 4 over 3x. And then when you do 4 over 3 times 3, the 3's are going to cancel out, and that's going to be plus 4 over here. And then we're going to get rid of this 1 by moving it over here. And this is our answer in y equals mx plus b form.